Look at this interesting infographic. Here we can see dozens of already operating and planned missions. Their goals are to study the Earth, the Moon, the Sun, the planets of the solar system, as well as galactic and extragalactic processes. You've probably noticed that next to the names of many missions, there is a red X. What do you think it means? I think you already suspect that nothing good will come out of it. You may have heard something about the recent problems at NASA, and the main reason of them is the budget cuts demanded by Trump and his administration. 24% cuts of the total budget and 47% cut of the budget specifically allocated to science, to research, especially fundamental space research. So the red X's in this image appear next to the names of missions that will be affected by these budget cuts. If nothing changes, these missions will either be cancelled entirely or see their funding severely reduced. This list includes many long-established missions that have been operating for quite some time, such as the Chandra telescope and the Juno spacecraft. And there are also missions that many scientists, and just people who love space like you and me, have been waiting for a long time. For example, the upcoming Venus missions, Da Vinci and Veritas. According to many experts, such a large number of cancelled or severely cut missions will cause irreparable damage to space science, and in the long run, not only to space science, but to science as a whole. And all of this is happening simply because specific people in a specific government of a specific country basically just didn't want to give money to scientists. This is also unfolding against the backdrop of general rise in public hostility towards science and scientists, the growing popularity of pseudoscience, and all kinds of conspiracy theories. So what are we supposed to do if the state stops funding science? If we stay within the space topic specifically, there will surely be those who, upon hearing such a question, will say something like this. Why do you even need these space agencies? Look at how many private space companies there are now. They do everything faster and cheaper. They'll take over. But the real question is, will they? For a long time, space was indeed exclusively a government domain. But in recent years, with the emergence of companies such as SpaceX, Blue Origin, Virgin Galactic, Rocket Lab, and others, the landscape has begun to change in certain areas. Will these and other private companies and investors really pour billions of dollars into fundamental or basic research if governments stop spending taxpayer money on science? There are different opinions on this, and there are even those who strongly argue that science should be stripped of public funding altogether and handed over to corporations. Today we'll try to figure out just how realistic that is, and it is not a simple question. Let's talk about why we even need space at all and fundamental science in general, and whether it might be better to spend this money on something more, as some say, useful. Wouldn't it be better to explore space with private money, under the guidance of effective managers, rather than using hard-earned public funds? What are private companies actually doing for space exploration and fundamental science today? What would happen if all of the science were handed over to corporations? Would Musk or Bezos build the next James Webb Space Telescope? Or if current trends continue, would this lead to the death of science? Well, I'm Andrei, and this is Cosmos Elementary. Many of you are probably interested in space, and for many of us, the structure of the universe and the study of it are interesting in and of themselves, even if they had absolutely no practical benefit at all. But we are in the minority, and many people don't care about space at all. I frequently see people leave comments on space-related content like, "So, what do I get out of this? How will my life change?" and so on. And sure, if tomorrow all space agencies in the world were to shut down and all astronomers, astrophysicists, and cosmologists were to abandon their work, most people around the world wouldn't feel any difference, at least not right away. Often, in order to explain to the average person why we need space exploration, people talk about so-called spin-off technologies. Technologies that were directly developed by space agencies or at their request, or technologies created based on space developments. Some of these technologies are ones many of you use every day. These include image sensors in digital cameras, scratch-resistant glass, memory foam, baby formula, air purifiers, cloud computing, solar panels, various materials, engines, and so on. All of these are undoubtedly important and useful inventions. But there are counter-arguments to these examples. How proportional is the return in the form of such spin-off technologies compared to the tens of billions of dollars spent every year on space research? Wouldn't it be more efficient to directly try to develop the needed technology rather than exploring space and hoping that something useful will emerge in the process? In some cases, it might indeed be more efficient when we have a clear and specific goal. But often we don't know in advance what will we need and what might emerge during the process. The fact that side inventions emerge in the process of exploring space is great, but this is not the main goal. It's more of a pleasant bonus. Actually, the concept of space exploration is quite broad. Beyond inventions, there are other examples of potential practical benefits that could convince even some skeptics. New, still emerging industries. Space tourism, for example, which could potentially generate a lot of money in the future. Resource extraction in space, on the moon and on asteroids. By the way, I've covered this topic separately. Also, energy production in space. Huge space power stations that send energy to Earth via microwave beams. Plus, some people, Elon Musk, talk about the need to start colonizing Mars as soon as possible, which of course is impossible without space technology. How good of an idea this is, not just small research missions, but full-scale colonization of Mars, is still an open question. For now, there are actually more arguments against such an idea, and I discussed them in detail in a video on this topic. In general, there are some arguments to be made about the obvious practical benefits of space research. But the thing is, that's far from all the space agencies, universities, institutes, and laboratories do. Besides, applied science, which aims using the scientific method and knowledge to achieve some kind of practical application. There's also fundamental science or basic research. And explaining why this is needed to a layperson is much harder. Fundamental science is experimental and theoretical research in search of new knowledge, without aiming for practical applications. When scientists pose a question that fundamental science can answer, they are not doing it in order to eventually create some useful technology. It's knowledge for the sake of knowledge. It is the pursuit of a deeper understanding of how different processes unfold and how everything in the world around us works, driven primarily not by prospect of financial gain, but by curiosity. In short, we want to understand how everything in the world works, and using the scientific method, we try to gain as much knowledge about it as possible. And with applied space science, again, everything is more or less clear. Medical or pharmaceutical research conducted in microgravity, which can help develop new treatments for cancer, Alzheimer's disease, and many others. Material science, and so on. But what do we gain from knowing what processes occur in Saturn's atmosphere? How many exoplanets orbit a particular star? What is the mass of the black hole at the center of a galaxy? And how fast is the universe expanding? Nothing. Knowledge about all this does not provide any direct practical benefit in the short term. It doesn't directly improve our lives, at least not quickly. Maybe it satisfies our curiosity, but even that is far from true for everyone. And yet, thousands upon thousands of scientists around the world are engaged in this very kind of fundamental science, and it takes a lot of money. So, it's no surprise that, especially when it comes to such research, ordinary people ask, why bother? Wouldn't it be better to direct money towards applied science or, building something, paving roads, feeding the hungry and stuff? Well, first of all, fundamental science is far from the largest item in the budget. And second, yes, the discoveries of fundamental science cannot be quickly or sometimes ever monetized. But the answer to why fundamental science is needed is right there in the name, fundamental. It's from Latin root fundamentum, which means foundation. Fundamental science forms the foundation of our knowledge about the world. Without understanding the laws of nature, it's impossible later to build concrete working technologies. Moreover, often the creation of a single technology requires a combination of different sciences. Why did the microprocessor appear in the 20th century and not, say, in 15th? I think even a person who isn't interested in science can understand that something like a processor can't just appear out of nowhere. For that, gradual development of engineering and fundamental sciences is necessary. For example, fields of physics like electrodynamics, thermodynamics, solid-state physics, and of course, quantum mechanics. All these disciplines developed gradually, answering one fundamental question after another. And at some point, the accumulated knowledge became sufficient to create computers. Moreover, if you look at individual studies in these disciplines that contributed, so to speak, to the final product, in many cases it would be completely unclear to most people how these individual studies could be applied in practice, what benefit they bring. But together they create that very foundation. And it's perfectly normal that a significant, if not the majority of such fundamental research will ultimately not lead directly to any practical application. But that's how science works. You have to try everything. Some of it will turn out to be useful in practice, some won't. And if you don't try, you won't know what will actually be useful. And even what did not directly lead to the emergence of, say, some technology was not useless. We still strengthened the foundation of our understanding of the world, of the universe. We made our capabilities broader. Those who like to criticize science, scientists, and fundamental research often latch into the perceived uselessness or sometimes even the apparent silliness of individual studies. What use could there be in studying whether pea seeds are wrinkled or smooth? And in the end, Gregor Mendel's experiments would form the foundation of modern genetics. Or here's an example closer to home. So the closest point of Mercury's orbit to the Sun, perihelion, shifts over time not by 5,557 arcseconds per century, as Newtonian mechanics predicts, but by 5,600, 43 arcseconds more. So what's the big deal? And then one person finds an answer. In the end, decades later, this makes it possible to create technologies such as GPS. There are other similar examples when scientists pursue a question that seems insignificant at first, but in the end leads to discoveries without which we can no longer imagine our lives. As for space specifically, even the study of processes that may seem far removed from our everyday lives, like star formation, the behavior of cosmic particles, or the nature of gravity, can ultimately lead to new methods of energy production, new materials of the future, new types of communication, and new ways of transportation, and many more technologies that we can't even imagine yet, but which would be impossible without a deeper understanding of the universe. Yes, sometimes the path from fundamental research to practical application can take decades, and often, and in fact most of the time, it doesn't lead to it at all. But again, we don't know in advance what will lead to such applications and what won't. And when we are simply trying to better understand how the universe works, practical application isn't necessary. Knowledge is valuable in itself. You can criticize scientists all you want for research that seems silly to a layperson, but how much has actually been created thanks to fundamental science, and how much thanks to its critics? And even if among these critics there are, let's say, engineers who built real things, could they have built them without the achievements of scientists accumulated over decades or even centuries? Of course not. And even if among those critics there are, let's say, engineers who built real things, could they have built them without the achievements of scientists accumulated over decades or even centuries? Of course not. So far, I focused on the even very delayed practical applications. But fundamental science has other benefits as well. It inspires young people to pursue science in general. Students who engage in science may not continue working in the field, but they go into other areas where they apply their skills. Science develops critical thinking, and yes, it satisfies our curiosity. I came across a good quote. Fundamental science isn't about the product, it's about the process. In general, it seems obvious that simply claiming that fundamental science is useless is short-sighted. And space sciences in particular study a huge number of processes and phenomena occurring on a wide range of scales, from the quantum level to the large-scale structure of the universe. And yes, no one is saying that science can't be criticized at all. Of course it can. That criticism, however, comes in very different forms. Some people use rhetoric on the level of conspiracy theorists, or they are just conspiracy theorists, claiming that science is some elite club that only lets very few in, which of course is not true. Undoubtedly, science has its procedures, primarily peer review, where articles are evaluated by other experts in the field, and just some guy who comes up with a new concept about the origin of the universe won't just publish his ideas in Nature or Science. Although, if he motivates it well and writes a proper article, he might just get it published. Prestigious scientific journals are considered prestigious not least because the articles published in them undergo rigorous peer review. And even there, sometimes the system fails, and articles have to be edited or even retracted because the authors made mistakes or even fudged a bit. Scientists are people too, and among them, not all of them are the most honest people. Humans are humans. At the same time, there is now an entire industry of quote-unquote predatory journals, where anyone can pay to publish almost anything, and then wave their article around as if it appeared in a scientific journal, claiming it proves their point. This is often done by various, well, let's say, alternative thinkers or people trying to sell something. It is obvious that the modern system of scientific journals is not perfect. One can also criticize, for example, the paywalls on many articles, and the overall economics of journals. Although nowadays the number of open access publications is steadily increasing. But that's a whole other story. In general, the peer review system isn't perfect, but for now, it's the best we have. And despite its flaws, it has been working fine for decades. Sometimes rhetoric similar to what you might hear from people who don't understand science, like why do we need black holes and dark matter, can come from people who are actually directly involved in science or used to be. For example, recently theoretical physicist and a YouTuber Sabine Hassenfelder has caused quite a stir with her statements. At some point she started releasing videos that contained progressively more extreme statements about science and scientists. At first she said that string theory is nonsense. Well, that's something you could still debate. Then she claimed that most research in particle physics is nonsense. That raises some questions. And then she goes on to say that, in general, most fundamental research in all of science is pointless. Hearing that from her is, of course, very strange, especially considering everything I've already said today about fundamental science. She justifies this, for example, by claiming that there has been little progress recently and almost no groundbreaking discoveries at all. That's not really the case. Just consider the Higgs boson and gravitational waves. But there is actually nothing strange about the fact that groundbreaking discoveries happen less often. Low-hanging fruits get picked first, and revolutionary discoveries like the theories of relativity or the emergence of quantum mechanics have already been made. As we go further, the subject of study becomes increasingly complex, and making a true revolutionary breakthrough in science gets much harder. That's why such discoveries happen less often. Not because scientists aren't trying. It's just that, even with our growing capabilities, it's becoming harder and harder. Debates about who should fund such science, including space science, have been going on for a long time. Sabine Hassenfelder herself even argues that fundamental science should be stripped of government funding. And what if this were done? Instead of governments, billionaires, the various Elon Musks of the world, and ordinary people donating money took it up. But the question is, would they really? And here we can do more than just speculate. We can also look at what's already happening right now, which is exactly what we're going to do next. For starters, we can try to Google general information about what percentage of fundamental science or basic research is funded by the government, and what by business or private individuals. And here we come across a 2017 publication in Science about the US, which states that the share of government funding for fundamental science, also called basic research, has fallen below 50%. So it turns out that, at least in the US, private companies already fund more than half of basic research. So they can. What's the argument then? But the thing is, basic research isn't all the same. This category also includes studies that could potentially have earlier opportunities for practical application. The same article mentions that the surge in private funding was driven not by the space industry or particle physics, but by the pharmaceutical industry. Pharmaceutical companies are perfectly willing to invest in fundamental research within their field, because it can realistically lead to the creation of new product. And it does. Just one drug, Ozempic, has brought in billions of dollars. So in general, this isn't the most telling metric, considering it includes research that already has good short-term commercial potential, and companies are willing to spend money on such research. But there is another interesting indicator. In one of my videos, I've already talked about this study. In it, the authors analyzed the funding sources for 91 research projects that led to Nobel Prizes in various fields of science. Authors of scientific papers are required to disclose their sources of funding. And guess what? Out of 91 studies that led to discoveries awarded the Nobel Prize, how many were directly funded by private companies? For only one of the studies did the authors indicate any corporate funding, and the authors of just 5 other studies were employees of private companies. In short, it's nowhere near 50%. And even here, imagine, even if the research is purely fundamental and won't lead to practical applications anytime soon, what a chance for a company to show off. What a reputation gain. We funded a study that won a Nobel Prize. But even so, we see that they're still not in a hurry. Or more precisely, their investments rarely lead to such discoveries. Interestingly, in the early stages of modern science, it was mostly funded by philanthropists, patrons, and private individuals. Back then, modern science funding programs simply didn't exist yet. But that couldn't continue forever, because science was becoming increasingly complex, requiring more and more investment and more sophisticated and expensive instruments. The construction of the Large Hadron Collider cost approximately $5 billion. It costs billions more for its operation, maintenance, repairs, and upgrades. This is a project spanning decades, made possible through the cooperation of dozens of countries and government scientific funds, not corporations. Even expensive experimental facilities, such as those in the field of nuclear fusion, like the ITER project, are funded by the governments of the member countries in the collaboration. Even though at first glance the potential benefits seem huge, creating a new source of cheap and virtually limitless energy. As for space, I've already mentioned today the emergence of new commercial space industry. Businesses are definitely moving into space, but what exactly is their role there? When people talk about private space companies, they primarily mean ones like SpaceX or Blue Origin. These are the biggest players, but there are quite a few others as well. Arianespace, Rocket Lab, Firefly Aerospace, and not just them. What are all these companies doing? Mostly, they're roughly speaking transportation companies. They develop and launch rockets and spacecraft that deliver payloads into orbit. There are private space companies that build satellites and plan to extract space resources, but what all these companies are not doing is fundamental science. Someone might object, but NASA actually works closely with private companies, doesn't it? They have a whole bunch of contractors who build various components for spacecraft, including strictly scientific ones. They create scientific instruments that later travel to the Moon, Mars, the Sun, Jupiter, and so on. That's true. NASA and some other space agencies as well often don't build all the instruments themselves, but outsource this to private companies, which can sometimes do it faster, more efficiently, and cheaper than if the agencies build the instruments on their own. This is often described as a mutually beneficial cooperation between government agencies and private companies. But here's the catch. Who's paying? It's the government agencies. They set a specific task, for example, the study of Saturn, and part of the instruments are ordered from private companies, bought with budget money. But if there is no research task, if NASA doesn't have budget money for such missions, who will pay the private companies? In fact, the cooperation between agencies and companies that exists today doesn't show at all that private companies would rush to conduct fundamental research with their own money. If anything, it suggests the opposite. This largely applies to companies like SpaceX, which also rely heavily on fulfilling government contracts. Except that a significant portion of SpaceX's revenue now comes from Starlink. But again, the fact that companies can make money without government contracts through the internet, launching satellites for other private companies, or space tourism doesn't at all suggest that they would be interested in funding fundamental research. Earlier today I mentioned the International Space Station. You could replace it with a private space station, and NASA is already running competitions and awarding grants here. But again, it's NASA doing it. Let's say the station modules are built not by agencies themselves and delivered not by the agency, but scientific research continues to be conducted on the station. Some of this research could very well be funded by businesses. Again, the ones that promise some practical application. Anything related to material science, developing new drugs. Here it's quite easy to imagine that such research could be funded by private companies. But who will fund a new X-ray telescope or a gamma ray detector? Even if they are installed on a private space station, the payments for these instruments, as well as for components of interplanetary spacecraft, will most likely come from space agencies. I have a question for those who think that all public funding should be taken away from scientists and all the fundamental research should be handed over to businesses. What's stopping businesses from doing this right now, if they can supposedly do it faster and more efficiently? Who has funded interplanetary missions so far? Governments and taxpayers. With whose money was the Hubble Space Telescope built? Taxpayer money. James Webb? All the other smaller space telescopes? The largest ground-based observatories? All funded by governments. Where is Jeff Bezos' space telescope? Where is Elon Musk's spacecraft that studies Jupiter? And it doesn't even have to be done by private space companies. Any business, investment fund, could simply finance the creation of a new revolutionary instrument like Hubble. So this could have happened a long time ago, even before private space companies existed. But why hasn't this happened? Why isn't it happening? Or almost nothing is happening? There are a few examples though, and I'll mention them later. But still, many missions, especially flagship ones, cost billions of dollars. What sense does it make for a private company whose main goal is profit to spend that kind of money on something like the James Webb Telescope, when it almost certainly will never pay back the investment? As a possible motivation, I can at least see the personal interest of the company owners. Elon Musk has this obsession with sending humans to Mars, but even here he's not doing too well. At least according to his own projections, humans should already be walking on Mars, but that goal is still far off. That's your efficient managers for you. Although here the problem is more likely due to overly confident predictions. And here's another factor. The goal itself is massive, landing the first humans on Mars. If SpaceX succeeds, it would be an enormous reputational achievement, not to mention a boost to ego and a way to go down in history. But studying the weather on Jupiter with a robotic probe, that's a much less flashy, eye-catching and appealing goal for the general public and even for the company itself. So I can understand why someone like Musk would be willing to spend billions on a flight to Mars. But even now, SpaceX isn't just ideologically spending money on developing Starship. They're also hoping to make money from it, continuing to deliver cargo to space, just potentially more efficiently. Now let's say that tomorrow all government funding for space science is cut. Which investors would get excited about pouring hundreds of millions, if not billions of dollars into building telescopes to study galaxies or interplanetary spacecraft to study planets? Again, I'm not talking about potential resource hunting research, I'm talking purely about fundamental missions. Why would they do it without any possibility of recouping their investment? And when there aren't any obvious reputational gains, like in the case of flight to Mars. Personally, I don't believe that business can fully replace funding for fundamental science. At best, I see that missions like those to other planets might be undertaken under some conditions, but only if there is some potential for profit. For example, a private company might send a spacecraft to Mars or Mercury in search of useful resources, and as an extra, add a few instruments with purely scientific goals, funded either by the company itself for PR purposes, or if scientific institutes manage to find the money themselves. When the legendary 300-meter Arecibo telescope was destroyed, the entire astronomical community mourned it. Did any corporation step in to fix it or build a replacement? Of course not, because why would they? Meanwhile, China has already built their 500-meter fast radio telescope. So my main point here is this. Right now, private space companies exist, but they focus on what brings or could bring profit in the relatively near future. And even if they do something related to science, it is still usually on behalf of the government space agencies and paid for with public funds. Nothing currently prevents a corporation from building, say, a flagship telescope or launching a robotic mission to another planet. And I don't think we necessarily have to wait until scientists are completely deprived of funding. If private companies had real motivation, they could do it right now, alongside the government. And again, possibly faster and more efficiently, as they claim. There are currently so many potential missions and instruments in limbo, and in large part because of insufficient or lack of funding. Full-fledged missions to Neptune and Uranus, landing missions to other planets, to the moons of the giant planets, various space interferometers, and so on and so forth. If large companies, investors, philanthropists had the will, so many amazing things could be developed and launched in just a few years. But they almost don't do it. I said almost. So they do something, right? Let's take a look at some examples. Honestly, I think this is quite telling. Even without specifically looking for information, if you just try to recall off the top of your head scientific space missions and projects that were funded entirely or mostly by private companies, no matter which well-known mission you point to, everywhere there is the hand of the government. I started looking deliberately, and I can't say that I managed to find many examples. For instance, some large corporations like Google and Microsoft fund scientific grants, which are awarded to individual research groups or scientists. For instance, there is the Google Research Program. Google provides $60,000 to $100,000 for individual research programs. I couldn't find the exact annual amount they spent on this, but as far as I understand, it's not huge. The total is on the order of millions of dollars. For a company with a market capitalization of almost $4 trillion, that's not even pocket change. It is a similar story with Microsoft. And also considering that they are constantly trying to optimize processes. In recent years, they've been laying off employees by the thousands. I can't imagine a world in which companies like that would be willing to spend billions on fundamental science. But for individual groups of scientists, their grants make life a little easier. Thanks, I guess. A substantial example of a fundamental space research program funded by a private individual or company, which immediately came to my mind, is of course the Breakthrough Initiatives created by Yuri Milner. Here we have two main branches. Breakthrough Listen is a program for searching for extraterrestrial life through radio surveys. And of course, Breakthrough Starshot. The plan is to send microprobes to the Alpha Centauri system. A total of $100 million is allocated for this over 10 years. Well, that's quite a fundamental science. Research within Breakthrough Listen is ongoing. Sending interstellar probes? Well, it still seems very far from being realized, and it's not even certain that it will ever happen. $100 million is clearly not enough. Estimates suggest that for an actual launch, you would need not hundreds of millions, but tens of billions of dollars. And most of the expenses would go toward building a super powerful laser array on Earth to accelerate the probes. And no private company is rushing to invest that kind of money in such endeavors, at least not yet. Here we also have to mention the SETI Institute, a group of organizations whose mission is to search for signals from extraterrestrial civilizations. Part of the SETI's research is funded by NASA grants, but some of it comes from donations by private individuals and companies. Their annual budget is actually small, usually around $25 to $30 million, but occasionally they receive very large donations. For example, in 2023, the foundation of Qualcomm co-founder Franklin Antonio, who had passed away the year before, donated a whopping $200 million to SETI. This is an interesting example and a significant investment. There's also a personal story. Franklin Antonio had worked with SETI for 12 years. And again, the goal, searching for extraterrestrial life, is very exciting and captivating. I think people will always donate to something like that. Quote-unquote boring topics, it's a big question. But I did find an entire interplanetary mission that could actually be launched. I've already mentioned Rocket Lab today. They've been working for several years on the Venus Life Finder mission. And if it flies, it could become the first private interplanetary mission. The company itself is building a small spacecraft that could fly to Venus and release a probe into its atmosphere in search of signs of life. And it would launch it, once again, on its own Electron rocket. The cost of such a mission is very modest, around $10 million, and it would be an interesting precedent. In fact, Rocket Lab CEO Peter Beck said that this project is more like a side hustle, something the company's employees do in their spare time. And it's not the start of a new direction in which the company would gather scientific data with its spacecraft and then sell it to clients, which again would be a commercial enterprise. In general, it's not hard to imagine that private companies could do something like this from time to time. Something inexpensive, interesting to the owners or individual employees, and something that's good for the company's reputation. But it's obvious that global fundamental science won't get very far with missions this small. Probably the largest share of participation of a fundamental scientific project identified as private that I was able to find. This is the GMT, the Giant Magellan Telescope. It's currently under construction with a primary mirror nearly 25 meters in diameter, made up of several separate circular segments. Here's just one of the segments during the manufacturing process. On the telescope's official website, it says that the project received the largest private funding share in the history of ground-based astronomy, $1 billion. That's roughly half of the estimated total cost. In reality, this funding still doesn't look quite like what someone might expect. No billionaire or Google or any other large company just came and gave $1 billion. The construction of the telescope is funded by an international group of 15 universities and research institutes. This means that part of funding comes from government sources, like the NSF, and part comes from universities which can be private, as in the US. Again, it's not exactly that picture, although an interesting example. There's also a plan to launch the first fully private space telescope. Of course, it's nowhere near Hubble. It has a 13-centimeter mirror, not 2.5 meters. 13 centimeters is the same diameter as the telescope that I have at home. This small observatory, about the size of a suitcase, is equipped with an ultraviolet spectrometer. It's actually an interesting project. The telescope was built in 3 years, and the mission is called low cost, although the exact price hasn't been disclosed. But again, it's not quite the same. Yes, the private company Blue Sky Space fully funded the creation and launch of this small telescope. But for what purpose? And research institutes will buy observing time on this telescope, so once again the research itself will still be funded in the traditional way. Here it's just the operator is private. In short, it's a business. It is reminiscent of how NASA buys components from contractors, but the government is the one paying. There are probably some other examples, but you'd still have to look for them. On the other hand, there are plenty of examples where scientific projects and research itself are funded by government in large amounts. The examples I found are more like exceptions to the rule. And even in many of them, the situation isn't that the business decided to invest in science for the sake of science. And I've said that more than once. Nothing stops private companies from doing this right now, if they had the desire. But still, let's imagine tomorrow the government said, "Go ahead, scientists, you're on your own." What would happen? Given the current situation with NASA, we can see that budget cuts already threaten cancellation of many missions. And significant money and years of work have already been invested in many of those missions. My bet is that corporations won't rush to fund those missions affected by the cuts. And what could happen if government funding for science disappeared completely and corporations did step in to take over? The scientific landscape would change, and not necessarily for the better. Right now, the choice of research topics is often made by scientists themselves. Yes, in some cases you still have to seek funding and get grants, but even so, a huge variety of research is currently being conducted. And it seems to me that if private companies became the sole investors, many of the studies I've talked about today, the ones that might seem silly to the average person, would be cut. Perhaps that would sound weird, but that reminds me of the modern gaming industry. In recent years, large publishers like Microsoft have been buying up gaming companies in bulk, promising to keep them and then laying off staff, or even shutting down entire studios. Sometimes they do this in completely illogical ways. The same goes for Microsoft. They can one day say, "We need small studios that make high-quality award-winning games," and in the same breath shut down Tango Gameworks, which had just won a bunch of awards for Hi-Fi Rush, and most importantly, the game was commercially successful. Like, what? But when you have to answer to investors and make sure that the line keeps going up, measures like that are often taken. Something tells me that fundamental science wouldn't fare any better if executives in suits were judging proposed research and asking questions like, "What's this trans-Neptunian object?" As a result, a number of studies that might seem useless to someone, but in reality help lay the foundation of global science, would shrink. Consequently, either investors would entirely choose what scientists study, or scientists would have to behave like influencers. In other words, they'd have to do some kind of scientific clickbait, choosing research topics or presenting them in a way that attracts funding. Also, private science would likely become much more isolated. Right now, fundamental science is done for the sake of knowledge, and that knowledge, once published, becomes accessible to the entire global scientific community, and in principle to anyone interested. You can go to an astrophysical database and find practically any scientific article in space sciences, not just from the last few decades, but even from centuries ago. Many of them are freely available, others require subscriptions, some are paid, but many of those are still accessible for free in the form of preprints. In any case, anyone who wants can access this knowledge. Openness and accessibility of knowledge are part of the scientific process. The results of one research group should be reproducible and verifiable by other scientists. Private companies operate very differently. After spending money on research, they won't rush to share their results with the world. Their main goal is, in any case, profit. They'll keep the knowledge for themselves, patent some of it. As a result, global science would turn into isolated islands, each on its own. Of course, even now there is some level of secrecy in certain fields, but when it comes to fundamental science, almost all of it is open. If it became closed, it would obviously slow down scientific progress and development. High-risk, high-investment projects like the James Webb Telescope or the Large Hadron Collider in such a world would seem, if not impossible, then highly unlikely. The question is, what would the attitude be toward, for example, safety in exclusively private organizations, or their impact on the environment? Right now, one private company wanted to create a massive satellite constellation, I'm talking about Starlink of course, and is doing it. And nobody seems to care that this has a major negative impact on astronomical observations and potentially even on the climate. How many projects like this would exist if everything in space were private? I'm sure I'm still missing something, but even the arguments I've already listed seem enough to understand that the scenario where all fundamental science is funded by private companies and individuals is not very promising. Fundamental science in particular would have a very hard time without government funding. At least in the US, at NASA, this is a very real possibility. Cutting the science budget by nearly 50% is telling. Fortunately, NASA isn't the only space agency in the world. There is also the European Space Agency and others. China in recent years has been doing a lot as well, including work in fundamental science. They build their own space station, they're sending spacecraft to the Moon, Mars. I've already mentioned the 500-meter radio telescope today. So a complete withdrawal of funding from fundamental science worldwide probably isn't what we need to worry about. But the trend is still rather worrying, even if we talk only about NASA. After all, they remain the world's largest space agency, launching the most spacecraft and making a major contribution to science. But I wouldn't be surprised if, even after all the arguments I've given, there are still some of you who think that we should take money away from the scientists and let the market decide. The market will decide, sure. But the question is, will that make things better for humanity? I think curiosity is one of humanity's greatest qualities, and trying to satisfy our curiosity about how the universe works doesn't seem like the worst way to spend money, time, and resources.